We're going to take a look at question 55. We did 53, I think, in class. So, starting with 55, you need to calculate the mass of a block of iron. I'm just going to kind of tell you how to do this one because it's pretty straightforward. So you've got dimensions. So step one would be to find the volume. All right, after you find the volume, you'll have it in cubic centimeters. If you multiply by the mass, the grams per cubic centimeter, then you'll have the mass. So you're going to multiply the cubic centimeters by the number of grams per cubic centimeter. Do you see what will happen to cubic centimeters? And then you'll have grams. That's 55. All right, now 57 really it's a special deal. It's like you got three problems in one. So the first thing you want to do is find the volume of each. And you're going to need to find the volume in the same units because when you multiply, you've got to be sure that the units are consistent. So on 57 part A, for the iron, you're going to have 81.5 multiplied by 2.1 multiplied by 1.6. Okay, so 81.5 times 2.1 times 1.6, and that answer is 273.84. All right. Then part B, you've got 2 units in meters and 1 in centimeters. So we're going to need to change them all to centimeters. I'm going to do that in my head. So we'd have 1,112 centimeters. You have to multiply by 100 centimeters per meter. Then you'd have 362 centimeters. Then you would have 0.003 centimeters. All right, so if you take 1212 times 362 times 0.003, you end up with 1,316. So 1,316 cubic centimeters. And then in part C, it's real easy to change for cubic centimeters because you've got 4.051 liters, so that's 4,051 milliliters, which is 4,051 cubic centimeters, because a milliliter and a cubic centimeter, same thing. Remember that? So now we need to multiply each one of those by the density of the respective thing. So 273.84 multiplied by, that'd be cubic centimeters, multiplied by the density of the iron, which is 0.998 grams per cubic centimeter. And then you would have the 1,316 cubic centimeters multiplied by the density of the aluminum, which is 2.7 grams per cubic centimeter. I just made a mistake. Did you catch me? It's early in the morning here. This should not be 0.998. This should be the iron's density, which is 7.86 grams per cubic centimeter. All right, and then the third one is for the water, and the water was 4,051 cubic centimeters. That's what gets multiplied by the 0.998. Whoops, 0.998 grams per cubic centimeter. All right, so we get these three numbers. So 273.84 times 7.86 is 2,152. And 1316 times 2.7 is 3,553. And 4,051 times 0.998 is 4,042. So we're supposed to arrange them in terms of increasing mass, and it looks like they are arranged in order of increasing mass. So that would be the iron, that would be the aluminum, and that would be the water. And there you have 57. All right, 58. I'm sorry, 59. We want to find the thickness of the foil, and the thickness of the foil is based on, really it's just a problem we did in advance. We did not do it in general, but we had a little sheet of foil and we needed to find its thickness. So we know that density is equal to mass divided by volume. But we know the mass of this piece of foil is how much? 2.568 grams. 2.568 grams. And we know the volume of the piece of foil is length times width times height. So we know the length and the width, but we don't know the thickness, which would be the height. So we know it's 22.86 centimeters, 22.86 centimeters on each side. So you'd have length times width times height, which we don't know. So I just call that h. The density we know is 2.7. Alright, so now all you have to do is solve for h. To do that, I'm running out of room on my PDF sheet here. To do that, what we need to do is multiply both sides by the things that are in the denominator. So you guys are all into math and you know how to solve the basic algebra things. So we're going to clear the denominator. So we're going to take the 2.70, I'm just going to say this verbally. So 2.70, I'm going to multiply that by 22.86 and multiply again by 22.86. Again, all I'm doing is just multiplying this number times the things down here. And that gives me 1410. Oops, forgot where I was writing here. 1410. So ignore this up here. Let's get rid of that. Okay, 1410, and that would be 0.96. We haven't talked about sig figs yet. We will. 492, and that's times h. Oops. Hit the wrong button on my little pen. That happens to me often in these things. There's an h right there. And that equals 2.568. And by the way, the unit on this I didn't put in. That'd be square centimeters times grams. See, we got grams here, centimeters and centimeters. So it's square centimeters times grams. I decided to come out this side to do this morning, so I'm sitting on my patio underneath a gutter on my house. There's water in the gutter, and the birds are taking a bird bath in the gutter, so it's raining on me here, even though it's bright and sunny, because the birds are splashing water on me. So this was not the best place to do this. But anyway, so much for that. So now we need to solve for h. We divide both sides by this number over here. So h, I'm going to just write it up here because I'm out of space. H is equal to 2.568 divided by 1410.96492. So we get 0.0018. So h equals 0.0018 centimeters. And that would be the thickness of our foil. And that would be the answer to 59. Alright, I told you I was going to get a new solutions manual. I got this thing in the mail. So maybe I can just look up the answers to the others two real quick and remind you what they were. Okay, so we did 51. In 51 we got 0.629 kilograms. I'll put these right here. So 51 was 0.629 kilograms, and in 53 the answer would have been 1.07 kilograms. Oops. And in 55 the answer was 10,000. No, 10,000. Let's see. 10,400, and that was grams. Okay, we did 49 also, didn't we? So 49, the answer was 0.79 grams per milliliter. And 47, the answer was 0.958. All right. So there's all the answers to the homework. Hope that was helpful. And I'll see you on Tuesday.